All right, we're working on number 9. We have the graph of y equals the square root of x. This is our x equals 0. And now I also have a straight line that is at x minus 2. So y-intercept at negative 2. And then the slope is 1. So I'm going to go, here's my y-intercept. I'm going to go up 1, right 1. And I'm going to make a straight line that goes through that. This is my line at y equals x minus 2. So I have to think about what area is bounded by those things. And the area, I'm going to use my highlighter. Some of you had cool colors. I was looking at your homework problems and I was like, whoa, look at those cool colors. All right, so here I am. There it is. There's my area bounded by those guys. All right, so the first thing that they want us to do is set it up as if my representative rectangle is Kat, I'm stopping for a second looking at your question. You were supposed to send in the 1 through 7 from 11.1, but I thought I had them from everybody. Let me look again. Oh, no. Did you do them? Okay, let me check you off. Okay. All right, first way you're going to do it, and this is on the left over here, it says with respect to x and a calculator. So they want actually answers for these guys. So in this case, if I make it with respect to x means that I have a vertical representative rectangle. And so if I'm looking at it with respect to x, I'm going to say it this way, WRT, with respect to x. That's my work here. So I know I need to figure out where these things, I need to know my bounds so that I can set up the integral. So job number 1, well, I know this bound, right? This is 0. That's fine. But if I figure out what that bound is, that's going to be my next step. Because remember, I'm doing my x values. I'm trying to find my area. I need my bounds to put on my integral, which means that I know it's going from 0 to something. The question is, what's that something? So I come over here and I'm thinking bounds, which means points of intersection. So I'm going to take the square root of x, and I'm going to set it equal to x minus 2. All right, well, how do you do that? You're looking at it going, wait a minute. Any thoughts on how you can make that better?
Square the x minus 2.
Yes, square both sides, exactly. You want to square both sides. Again, you got to keep the algebra balance, right? So I don't want the square root anymore. I'm going to have to square both sides. So that means that if I take the square root of x and square it, I get an x. If I square this guy, I get an x squared minus 4x plus 4. Can you do that fast in your head too now? And then I'm going to put everything on the same side so I can set it equal to 0. X squared minus 4x. Oh, wait, actually, it is a minus 5x, right? Bringing that other x over. And then plus 4 equal to 0. Does that work? Did I? Yeah, x minus 4, right? And x minus 1. So x equals 4 and x equals 1. No, I know that there's a mistake in there. Yes?
I think the 1 comes from, like, you know how for square root of graphs, they sometimes don't do the plus and minus, and it goes like this, like it has like the top part and the bottom part?
Yeah.
And the x plus 1 is the bottom part, because it would be a lower number, because the x minus 2 would cross that at a lower x value. You know what I'm trying to say?
I do know what you're trying to say. And if you think about plugging, like if you plug these in, like obviously you can look at this and say, wait a minute, that doesn't look quite right to me. There's got to be something more going on, and that's exactly what you're questioning, Sairaj, which is good. If I look at it, I know I have x values of either 4 or 1, And it does have to do with the whole plus or minus thing, but let's plug it in. If I plug a 1 in, watch what happens. If I plug a 1 in, I get a negative 1 here and a positive 1 there. Right? That doesn't work. So it's like an extraneous solution to this whole thing. This one will not yield you an equal place. But if I put a 4 in there, 4 minus 2 is 2, and the square root of 4 is 2. That works. So it's almost as if this is an extraneous solution in the midst of it. All right, so this coordinate right here is going to be the coordinate 4, 2, where x is 4, y is 2. Remember, I'm doing this with respect to x. So the x value is 4. That's what goes here as my upper bound. Now let's set up the integral. The integral is the top. Look at where the top of your rectangle hits. The top is going to be your square root of x graph. Minus the bottom is the line. The bottom of my rectangle hits the line. And the line is x minus 2. And then this whole thing is with respect to x. So they want us to use our calculator. They say you can use your calculator for this one. So if you go to your calculator and plug this in, I am going to go to, you can do this a couple different ways, but I'm going to go to my calculate menu in the home, number 2, and I'm integrating. I'm going to use an extra set of parentheses to start this out. I like x, instead of square roots, I'd usually do x to the 1/2 power, x to the 0.5. Close that parenthesis, minus, open a new one, x minus 2. Close that guy, and then it's comma x, comma 0, comma 4, close it up, and I get an answer of 16/3. Did I do that too fast? You got a lot of loving going on over there, Brenna. I'm loving it. You're making me miss my puppy at home. He had the biggest eyes when I left this morning. Like, where are you going, Mama? All right, 16/3. We know what the area is. Here it is. I'm going to take a quick pause. Questions before we go the other way? Because now we're going to do it with respect to y, and it changes things up a lot. Okie doke. So here's what I want you to do. Well, you don't have to. I'm going to redraw my picture so that I can show you the rectangles a little differently. So if I draw it just the same thing we had, we have the square root graph. If you have room to draw it, that's cool. If not, just follow me here. And x equals 0. This is my highlighted area. All right, so here we're going to go. We're going to do the same exact problem. They want to know what's the area, but they want us to do it now with respect to y. Now, as far as your sheet goes, they're looking for you, if you were still working on the sheet here, they're looking over here on this side. So if I'm looking at the whole thing, we did it with respect to x, we drew the picture here, and now we're going to do it with respect to y. So that's where I'm at with this whole thing. I'm on extra paper because I write big. If I were to start looking at my representative rectangle for this, because now I'm going the other way, I'm going horizontally with that rectangle, it would look like this, right? Draw a horizontal one. And again, if you couldn't draw this because of space, just so you can watch mine. And I'm like, that's cool. That's really cool, because the right-hand side hits the line, the left-hand side hits the square root of x graph. However, what happens if I drew my rectangle down here? What if I did it under the x-axis and drew it there? Now my right is the line and my left is the y-axis. It changed. What's on the right versus the left changed when I hit that x-axis, which means I'm going to have to do this as two separate integrals because the right and the left are different in those locations. Make sense?
Miss Winter.
Yeah.
How did they change?
Okay, so you're okay with me drawing the two rectangles, right?
Yeah.
Okay, so the right side of this rectangle hits the line and the left side hits the square root graph.
Uh-huh.
But when I come down here, now the right hand side hits the line, but the left hand side hits the y-axis.
Oh, okay.
So it's different. So really, as soon as you cross this x-axis, you've got a different situation going on. So you got to set it up as two separate integrals because of that. Now remember, this coordinate here was 4, 2. You don't have to redo your bounds. And this coordinate down here is 0, -2, right? And where does the change occur? And the change occurs right here when x equals 0, when y equals 0, right? At that place. All right, so let's first, while we're on that concept, got that whole thing in our brain, we're going to set up, this is going to be a long one, because we've got to do two separate things. So the first integral is going to go, if I'm doing it in order, from my y value, remember these are y values with respect to y, so my y value here is -2 to 0. -2 to 0, it's doing one thing, and then it's doing something else from 0 to +2. Remember the y coordinate up here at this coordinate. These are going to be with respect to y. Okay, so here's the next piece. If I'm doing these with respect to y, remember what happens with these equations up here. These equations have to be changed so that they're solved for x. So I've got to go back, and so that I have everything in terms of y, I have to go back up here to these equations and solve them for x. So if I do that, this one's going to be the same thing as, I'm going to do it in a different color here. This guy's going to be the same thing as x equals, bring the 2 over, y plus 2. And this one, if I solve for x, I have to square both sides. This one's going to be x equals y squared. And they're the ones that I'm going to have to use in my integral that's with respect to y. All right, let's go to the first one. That's this section here. The right side of the rectangle hits the line, so my line is y plus 2. The left-hand side hits the axis. Well, that's just 0, so I don't necessarily have to say anything about that. But you could, if you wanted to, just for fun, for kicks and giggles, call that a -0. And that's with respect to y. Now I'm going to go to the upper part here. The right side of my rectangle hits the line. The line is called y plus 2. The left-hand side hits the square root graph, which I'm calling y squared. And there it is. So, if we go to the calculator, again, since they said we could, I'm going to go back and keep it in my home menu, F3, the integral. The fact that these are y's, it doesn't matter what the variable is that you put into the calculator. It's okay to just keep it as x's. It'll understand it just the same. So I am putting in a x plus 2, comma x, comma -2, comma 0, close it up, and it tells me that my first area has a value of 2. So that's this guy. Second area is a little bit more complicated. Back there again, F3, number 2. I am going to use extra parentheses on this guy. So open up a parenthesis, x plus 2, close that, minus parenthesis x squared, close that, comma x, comma 0, comma 2, close it up, and I get 10/3. All right, so if I have 2 plus 10/3, 2 is the same thing if I were in thirds as 6/3 plus 10/3 gives me 16/3, which is what I know the area was going the other way. The area number is not going to change, right? It's still the same area whether you're looking at it from top to bottom or whether you're looking at it from left to right. So you can always kind of check yourself. I know, Sairaj, you're a good checker. So a way to check yourself with these is to go the other way. Questions on that?
Ms. Winter?
Yeah.
So I like when we're trying to find where the y meets the x axis, you know when the two intersect at up at the top at 4, 2.
Yeah, yeah.
So if you make the you know how we did x instead of y, we made it with respect to y, I think, for this one, right? The bottom one.
Yes.
If you make them equal to each other, you get the points 2 and -1.
Yes.
And if you plug them back in, none of them are extraneous. A -1 will work for both of the the y, the equations.
A -1 would work, but the problem is we got a +1.
I'm talking about the bottom one, with respect to y. I'm sorry, with respect to y one, where it's you get this if you were to make those equations the y plus 2 equals to y squared, you get solutions 2 and -1, and both of those solutions would work if you plug them back into those equations.
The coordinates don't change though. Your coordinates of intersection, even though if you algebraically substitute in the values you're talking about, these coordinates are not changing. They are steadfast. So you know that the one coordinate where it intersects is down here at 0, -2. You know the other one's at 4, 2. The one that was at x equals 1 isn't part of it.
Okay.
Know what I mean?
Yeah.
So right off the bat, you just ignore this whole thing. And ignore it even for going down into the second part of the problem. Because you can see that that value of 1 still doesn't play a part in any of that picture.
Okay.
Does that make sense?
Yeah. Yeah. Thank you.
You're welcome. And Abby, you do not have to redraw the graph. I just wanted to do it because I didn't want to put them all in the same picture and confuse you with the horizontals versus the verticals. So no, you do not need to redraw the picture at all. I wanted to kind of keep it separate because when you go into this whole doing it with respect to y, I think that our brains don't think that way as well. At least mine doesn't. I'm totally a vertical thinker when I'm looking at these things. So it was easier for me to show you with a separate picture, but you don't have to redraw it now. All right, the last one I want to look at with you, I think, is number 12, but it's a similar kind of problem. It's just the question got a lot harder. So here we are with number 12. And this guy is an e to the x squared minus 2, as well as a square root graph that's a 4 minus x squared. This one is totally a graphing calculator question in the midst of trying to set it all up. So we have to sketch the graph first, we have to do it with respect to x, and then do it with respect to y. So same question as number 9 was, just more complicated pictures. And so again, I'm going to take other paper and I want to look at what this thing really looks like. All right, so we're going to go to the calculator and put these in. But I'm going to show you the general picture for number 12. Here's what you're going to get. You're going to get part of it that looks like this. And that part is your square root graph. So this part, it's a semicircle, and it's y equals the square root of 4 minus x squared. And then you've got this e to the x squared minus 2. Well, he's going to come like this. This guy is y equals e to the x squared minus 2. So before we go, we're going to graph it on the calculator as well, because the reason we're going to find, well, there's a couple different ways we can do it. We need to know what these points of intersection are, right? I need to know what these guys are. And I need to know, actually, I need to know my y values too, right? Because we're going to do it with respect to x and with respect to y. But for now, let's just look at what these two values would be. So we need to find those points of intersection. All right. Here's my shaded part. And I kind of like the with respect to x, because you can see what's on top doesn't change versus what's on the bottom. If I make my representative rectangle is going to be that guy there. And I can see the top is always going to be this square root graph, and the bottom is always going to be this e to the x squared graph. So it's not going to change. The deal is, though, to find this with respect to x, I need to know what the bounds are. All right, so that's my task. Are you ready on the calculator? So you're going to, in this case, it's probably easier to do it from the graph. You can also use the solve feature on your calculator to figure out what that value would be. Set those two things equal to one another. It might come out pretty, I don't know. I'm going to try it with the graph. So one of the graphs is e to the x squared and then minus 2. Watch, you want to put that x squared in parentheses. I think you can see that on my screen. I like these calculators because then it literally puts the visual of what you put in there, so you can make sure that it looks the same as what you're trying to put in there. So there's the e to the x squared. Then the other one I have is, I'm going to use parentheses in my y2, parentheses 4 minus x squared. And then that's square rooted, so I'm going to raise that to the 0.5 power, to the 1/2 power. And then I'm going to graph my two graphs. It's thinking. Busy. All right, there it is. All right, let me show you how to find your points of intersection. That is in the math menu, which is F5. And down here, number 5 says intersection. Now you want to come with your left arrow, you want to kind of get close to where it is. And what it says is first curve. You want it blinking on, it doesn't matter which one you pick first, but right now mine's blinking on the parabola part. So I'm going to say, yep, that's my first curve. And then it automatically takes you to the second curve and starts blinking there. And you just want to be in the neighborhood of where that point of intersection is. Press enter again, and it says a lower bound. Well, you can see that it's somewhere, I don't know. Are you below? Like, make sure you're blinking below. And you can say, yep, I'm blinking below. And then you want to kind of go above it for your upper bound. Oop, my bad. I gotta start over. Did anybody get it? Quicker on the draw than me. All right, first curve, second curve. Lower bound, you can even input numbers. I know it's somewhere between -3 and 0. And now it's going to tell me it's busy. Busy thinking? No solution. All right, I'm looking at my chat. Did anybody get a solution? I got a whole lot of nothing. Okay. Your calc died. Oh. Yeah, that could be a problem. All right, well, for sake of time, because we've got like 5 minutes here, let me tell you what go to the, here's my thinking. Go to the solve menu. If you go to the, if you try the, Abby, try it out while I chit chat here. If you use the solve menu and set it equal to set them equal to one another and have it solve for x and then put a comma x and close it up, that should give you these values. But here's the coordinates, just for the sake of our time here. Negative 1.137 with 1.645 is the y value, 1.645. And this one over here, because of symmetry, guess what it is? 1.137 positive 1.645. All right, knowing those bounds, they're my x's, then I can set up my integral. So my integral are the x's, I'm with respect to x. So the lowest one is a negative 1.137. The highest one is a 1.137, my x's. My equations are going to be the top minus the bottom. The top is my square root graph, 4 minus x squared. The bottom is my parabola type graph, the e to the x squared minus 2. And this guy is with respect to x. All right, when you go to your calculator and plug those values in, you're looking for an answer that is 5.0496. So you can try that in the calc and test that out.
Miss Winter, I thought it was top minus bottom.
Did I do that wrong? Because yeah, it is top minus bottom. The top is this guy. Top is this guy.
Oh, I have the wrong equation.
Okay, no, that's okay. You're right to question me, Sairaj. You know that. Yeah, I do have it set up right. The top part is your square root graph, and the bottom part is your e to the x squared minus 2. All right, I am obviously not going to be able to show you how to do it with the with going with respect to y, but we should probably come back and revisit it. I don't think you have. Let me look, make sure you don't have any homework problems that are going to. Here, I'll give you a quick view of it. All right, here's the with respect to y. The problem is that you need to change this into being, you need to solve for x. You remember that back from, yeah, look at Brenna. You see why I'm stopping where I'm at. You need to solve this for x, which means you need to do logarithms to be able to bring it down to be able to figure that out. We don't have time for that with 1 minute left, so we're not going to go there and show you that direction. There are no other problems that will do that to you in the homework. So we will come back and revisit this because it's an interesting way to look at things. But we're not going to have time to do that right now. All right, so let me go back to where you are at.